You ready? Let's learn some math. Math, 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 math. Math, 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 math. Math, 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 math. Come join me on an adventure. There's so much to explore. Numbers, shapes, and graphs to plot. Solve the problems, connect the dots. Algebra, geometry.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Math, 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 math. Math, 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 math.
Welcome to Math Matters. This is our third episode, and today we'll be looking at algebra. Thank you for joining us today. But before we start algebra, let us look at the challenge from last week. The challenge solution for a rectangular fish tank, 30 centimeters by 15 centimeters by 17 centimeters is 1/3 full of water. What volume of water is needed to completely fill the fish tank? Let us do some calculations. Let us recap. The dimensions for the fish tank are 30 centimeters by 15 centimeters by 17 centimeters. Now, we know this shape is a cuboid, so we will be using the length times the width times the height, which is, again, 15 centimeters multiplied by 30 centimeters multiplied by 17 centimeters. The product of these three dimensions is 7,650 centimeters cubed. Remember, volume is always measured in cubed units. We have established that it is 1/3 full of water, and we want to know how much more is needed to completely fill the tank. So let's find a third of the complete volume of the cuboid. So a third of 7,650 centimeters cubed is equal to 2,550 centimeters cubed. Now we have established that 2,550 centimeters cubed is a third of the total volume of the fish tank. We will now have to calculate how much more is needed. To do so, we will have to find the difference between the third and the complete volume. So 7,650 centimeters cubed subtract 2,550 centimeters cubed, and the difference is 5,100 centimeters cubed. So, if you want to recheck, if you add the third and the difference, you will get the complete volume of 7,650. Just a reminder, remember, we will be issuing challenge questions every week, and be sure to participate. We will see you when we get back.
Join me on an adventure. There's so much to explore. Numbers, shapes, and graphs to plot. Solve the problems, connect the dots. Algebra, geometry.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Welcome back. Our topic today is algebra. And I know many of you out there, when you hear algebra, you say, why are they mixing letters with numbers? But it is that part of mathematics where we use letters which become variable for unknown amounts, unknown values. And believe it or not, we use algebra every day in our lives. We use it a lot to solve a lot of compound, complex problems. Now, let us look at a real-world example. A A pound of potato is sold for $4 per pound. And if I want to buy 2 pounds, I will then pay 2 times 4. If I want to pay for 5 pounds, I will pay the product of 5 times 4 or 10 times 4. But in algebra, instead of saying 2, 5, and 10, those values are represented by a letter, in this case, n. N pounds cost n times 4. For instance, n times 4 can also be seen as 4n. Writing in algebra, the multiplication sign is usually omitted or left out. So if you see that, please note that the operation to be performed is multiplication. When it comes to algebra, remember, there are some things that we need to keep in mind, such as the coefficient. The coefficient is the number that is placed before the variable. So the coefficient of x cubed is 2. Let us look at another aspect of our algebraic expression, the variable. That is the letter or the symbol that represents the quantity that can change. Here, the variable is an x. I'm sure many have seen y's and z's and t's. They are just symbols. They're just letter symbols that represent different amount of quantities. The exponent. That is that little 3 above the x. That exponent is also called the power or the index. This number tells us the amount of time we multiply the base. So in this case, the base should be multiplied by itself 3 times. This is the power of 3. And we have the constant. That number, that symbol whose quantity does not change, unlike the variable. The constant remains the same. Now we have 2x cubed and 5. 2x cubed is one term, and 5 is also another term. So our algebraic expressions are made up of many terms. Sometimes 2 could also be one term. There are patterns in algebra that we need to pay close attention to. Remember that the exponent represents the number of times the base should be multiplied by itself. When we multiply the same base and exponents are involved, we add the powers. Those are also what we call indices. So in our example here, we have 3 to the 5th power multiplied by 3 to the 2nd power. That would be equal to 3 to the 7th power. Or what if we don't have numbers? We have variables. We have x to the 4th power multiplied by x. Whenever we see x by itself, we know that it has an indice of 1. So therefore, it would be x to the 4th power plus 1, which is equal to x to the 5th power. When we divide same base terms with exponents, we do the inverse of the multiplication. We divide, therefore we subtract the exponents. Just like in our example, 2 to the 5th power divided by 2 to the 2nd power is equal to 2 to the 5th power minus 2, which is 2 to the 3rd power. Or when we're using variables, we have x to the 4th power divided by x, which would be x to the 1st power. That is x to the 4th power minus 1, which equals to x to the 3rd power. And we need to keep those in mind, for we will need them when we factorize. Side note, any number raised to the power of 0 is equal to 1. Our example is 2020 raised to the power of 0 is equal to 1. And any number raised to the power of 1 is equal to that number. 2020 to the power of 1 is 2020. Let's take a break to hear from our sponsors, and when we come back, we will be delving right into factorization.
Take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Geometry, add and subtract.
Welcome back. We're glad you're still with us. Now let us look at factorizing. Remember, algebra is nothing to be afraid of. But we're going to look at some key terms we will need to help us factorize. The first term we will look at is factor. What is a factor? A factor is a number that divides another number equally. Like in our example, if we divide 6 by 2, we get 3 equal shares. And if we divide 6 by 3, we get 2 equal shares. So 2 times 3 is equal to 6. And that's because when we divide 6 by either of those factors, we get equal shares. And expressions like x squared plus 4x plus 3 also have factors. Our first factor is x plus 3, and our next factor is x plus 1. When we multiply those factors, those terms, we will end up with x squared plus 4x plus 3. Factorizing. Now, factorizing is a process of finding the factors to multiply together to get an expression. So, 3x plus 6 is the same as 3, open bracket, x plus 2. When we multiply 3 and x, we get 3x. And when we multiply 3 times 2, we get 6. Remember, anytime you see a number outside of a bracket, it means that all the terms inside the bracket should be multiplied by that number outside the bracket, therefore creating factors. Another term to look at is the highest common factors. Many of us have been doing this since we've been going to primary school. You know, HCF, the largest term that can be divided exactly into each of 2 or more numbers. For example, we have 3a plus 5ab plus 1b. 3 and 1 are the 2 factors of 3. Those factors equally divide 3. And we should note that 3 is a prime number, so it only has 2 factors, as well as 5. That's 5 and 1, those are the factors, and 1 only has 1 factor. So the HCF of 3, 5, and 1 is 1 because that's the highest number that can divide each number equally. That means there is no remainder. It is shared equally. And the last term we will look at is the distributive property or the distributive law. The simplification of algebraic expressions by breaking up into sums, differences of product to calculate the values of variables. And remember, we know that the letters in algebra, those are the variables. So we have an expression here. 4, open bracket, x plus 3. That is the same as 4x plus 12. When we multiply 4 by x, we get 4x, and 4 by 3, we get 12. The product is 12. So we have distributed the terms there. So 4x plus 3 is the same as 4, open bracket, x times 3 when factorized. Let us start factorizing by going step by step. Step 1. List the factors of the coefficient in each term. This has 2 coefficients. And remember, our coefficient is the number before the letter, the variable. So we have 8 as a coefficient and 4 as the other coefficient. The factors of 8 are 1, 2, 4, 8. And the factor of 4 are 1, 2, and 4. Remember that HCF that we looked at just a while ago? The highest number that can divide 8 and 4 equally is 4. So we have just found our HCF. So the highest common factor is 4. And that's our step 2. Step 3, we apply the distributive law. Whenever we multiply 4 and 2a, we will get a product of 8a. And when we multiply 4 by b, we get the product of 4b, which gives us 8a subtract 4b. Now let us try some factorizing. Don't go anywhere. We'll be right back.
Let's learn some math.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter.
Now let's factorize. Remember, there are 3 steps. So our first step, we're going to apply to expression 1 is to find the common factor, the highest common factor. And though we don't have any numbers, we can still find the highest common factor with these terms. We have px plus py plus pz. If we look at each term, we will realize that each of them has a p. Now, remember, we always multiply what's on the outside of the bracket by what's on the inside. So what goes on the inside? In order to do that, let us see. We have px, and we know our factor is p. If we divide px by p, we cancel out the p's and we have x, so the x goes here. And we can do the same for pz and py. So that will leave us with a y and a z. When we multiply all that's inside the bracket by what's outside, we will get px plus py plus pz. Factorization, we did our first one. Let's try number 2. We have the expression 4p plus 2pr plus 6pz. Here we have coefficients in our terms. Now, a coefficient helps us to know what's the number, but we also have variables that are common, that has commonality as well. So, what's the HCF of 4p, 2pr, and 6p? Each of the terms has a p, and they have a coefficient of 2, 4, and 6. What's the highest factor that can divide 2, 4, and 6? That would be 2. So our highest common factor would be 2p. Now, just like before, to find what goes in the bracket, we divide our terms by 2p. So on a side note, we have 4p, and we know we have 2p as our factor, and we know that 4 divided by 2, or 2 into 4, is 2. But since we already have a p outside, and we see here that our p's are cancelled, we only need to write the 2. Plus 2pr. 2pr. Keeping the same rule, our 2p cancel out our 2p's, we only left with r. And we can follow that for the 6. So we know that 2p into 6pz would be 3z, because our 2p will cancel out, our p's will cancel out our p, and 6 divided by 2 gives us 3. So we end up with 3z. Another factorization is completed. So let us now factorize expression 3. Here we have coefficients, variables, and indices in this expression. What's the highest common factor, since they both don't have coefficients again? But they both have y. Remember, when we talk about exponents, it's the amount of time we multiply the number of variable by itself. So if we expand this expression, it would be 4 times y times y times z. And that would be subtracted by y times y times y, which is y cubed, or y to the 3rd power. Now, what's the highest common factor they have? Both term has 2 y's. And when we multiply a y by itself, we make squares. So our highest common factor would be y squared. So what is left to put in the bracket? We have a 4 and a z. So 4z goes into the bracket, subtracted by y, because we only have one y remaining. When we multiply what's in the bracket by what's outside the bracket, we will get 4y squared z subtract y to the third power y cubed.
Now we're going to take a break and we will be hearing from our sponsors. When we come back, we will be finding the difference of two squares as we continue factorization in algebra.
Join me on an adventure. There's so much to explore. Numbers, shapes, and graphs to plot. Solve the problems, connect the dots. Algebra, geometry.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Welcome back. Let us continue with our factorization by finding the difference of two squares. What's the difference of two squares, you may ask? The difference of two squares is a type of quadratic factorization used when an algebraic expression is made up of a squared term subtracted from another squared term. To factorize expressions in the form of a squared minus b squared, we need double brackets. There are some simple steps to follow. Let's look at those steps. Step 1, write down two brackets. Step 2, find the square root of the first term and write it on the left-hand side of both brackets. Step 3, find the square root of the last term and write it on the right-hand side of both brackets. Lastly, step 4, put a plus in the middle of one bracket and a subtraction sign in the middle of the other bracket. Now we have looked at the steps of finding the difference of two squares. Let us look at an example. Here we have an expression a squared subtract b squared. Remember, we need two brackets. So we have our two brackets, and now we're going to find the square root of the first term. That is a squared. The square root of a squared is a. So on the left-hand side of both brackets, we write a. Now we go to term 2. That's b squared. To find the square root of b squared, that's b. So we write the b on the right-hand side of both brackets. Our last step is to put in our symbols. One symbol will be a plus sign, and the other would be a subtraction sign. So in our first bracket, we put the plus sign, and in the final bracket, we put our subtraction sign. There we have factorized our expression. Let's do some practice. Our first expression is x squared minus 36. Our step 1, remember, it tells us that we need to have two brackets. And we've been finding the square root of the different terms. The square root just simply means what do I multiply by itself to get back the term that we are looking at. So what do we multiply to get x squared by itself? X. So the square root of x squared is x. So I write that on the left-hand side of both brackets. Then we go to our next term, that's 36. What's the square root of 36? What do I multiply by itself to get 36? That number is 6. So I write 6 on the right-hand side of both brackets. And our last step, we add our operation signs. There you have it, the difference of two squares. Now, let us work out our second expression. That's 49 x squared subtract 121. We need our brackets, step 1. Step 2, we find the square root of 49x squared. What's the root of 49x squared? What do I multiply by itself to get 49x squared? That would be 7x. So we write that in both brackets on the left-hand side. But this time, our first bracket would be a minus sign, and our second bracket would be a plus sign, because it doesn't matter which bracket the operation sign goes, as long as each has an operation sign. Now, what do I multiply by itself to get 121? And that would be 11. So I write that in both brackets on the right-hand side. Let us factorize our final expression. 16x to the fourth power subtract, that should be 81y to the fourth power. And with our corrected expression, we start with our brackets, and we find the square root of 16x to the fourth power, which would be 4x to the second power. We're going to put our addition sign, and we are going to write 4x to the second power, and we will put our subtraction sign. Now, what's the square root of 81y to the fourth power? That's 9. So 9y squared. And we will write 9y squared on the next side of the bracket. We have now factorized 6x to the fourth power minus 81y to the fourth power. But we also have a bracket here with 2 squares, so we can further factorize. So we are keeping our first bracket, and we will then factorize our second bracket. So the square root of 4x squared is 2x. And we write that in both brackets. And remember our operation signs. And the square root of 9y squared would be 3y. So here we have it, our factorization of our 3 expressions. It wasn't that hard now, was it? You can do it on your own. Here is our challenge question. As promised, our challenge question for this week. Factorize completely. The following expression represents the area of a rectangle. 169x squared minus 25y squared. Find the length and width in terms of x and y. Thank you for joining us this evening. And we hope to see you next week when Mr. Lennon returns with Algebra. Remember, send in your answers by Wednesday, 6 p.m. They must be accurate, and there are prizes to be won. Have a pleasant evening.
Come, take a journey with us each Monday from 5:30 to 6:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.